So we're going to do just a brief video on reciprocals. A lot of people struggle with this aspect of when you're trying to rearrange equations and you're going to have to divide something by a fraction, and it gets a bit confusing. So let's imagine that a over b. We want to divide. Now let's say that a over b, and then we're going to divide it by c over d. So how do we do that? Well, it looks a bit complicated. Let's imagine that we did it with the using some of the tricks we know already. We'd go a over b, and then we put that in brackets, and we go over c over d. So what do we? I mean, it's just a bit of a mess, isn't it? Like, how do we get around this? Well, there is just a cunning little trick, and I will probably prove it as well. But for now, I'll just tell it that with the second one, I can flip it. If what I'm saying is that if a over b is so basically a over b divided by c over d. This is identical. We can do a three parallel lines, which means identical to a over b times d over c. So it just so happens that's the case. Now I can prove it in a moment, but now we've got that, it's a lot easier because that's just going to be equal to a d over bc. So this can be applied to this situation. We're trying to divide 1 by a half. So 1 divided by a half. When I divide a fraction, it's the same as multiplying it by the upside down fraction. So this is identical to 1, rather than divide by a half, it's times by the upside down version of a half, which is, instead of 1 over 2, it's 2 over 1. So I'm using this rule here, which I may prove in a moment, but I haven't proved it. I'm just telling you that it is the case that if I divide something by a fraction, then the fraction I'm dividing it by, I can flip it upside down and imagine I'm timesing it. It means the same thing. It's the same thing, but it's not often seen. Why is that the same thing? It's a bit confusing in some cases. For now, we're just going to say that it is, and just trust that it is. So that in this example would be 2. So that's the application of this rule. Now let's try to prove the rule. So I'll delete that. I'll try to see why is that the case. So I'll make it a little bit easier, and we'll make a over b just a. So a, and we want to divide it. In fact, let's think about this. A divided by c over d. Right, okay. So it turns out that I've actually forgotten the proof for this. But never mind. You just have to trust me here. I'm sure at some later date I'm going to end up posting the proof of why this is the case. For now, I've just forgotten the reason why. You just have to trust me. I can give a brief example. We know. I just a moment ago I proved that 1 divided by a half. I didn't prove it. I said it is equal to 2. Well, what that is actually saying is how many halves go into 1. Well, 2 halves go into 1, and so that's how I know that this sum is correct. So basically a half, 1. Anyway, that's how you do that. So that's the application of the rule, and stay tuned for when we do the actual proof of the rule.